This video will work through problem 18.2 from Gapenski's Healthcare Finance 6th edition. Okay, in 18.2, Big Sky plans to obtain an MRI scanner. Cost is $1.5 million, estimated 4-year useful life. They can obtain a bank loan for the entire amount and buy the MRI, or they can lease it. So we've got a bunch of facts. The MRI is going to be in a 3-year class for tax depreciation, even though it has a 4-year useful life. Maintenance expenses of $75,000 are payable, whether it's leased or purchased. So we have to pay maintenance on it, even if it is a lease. Marginal tax rate of 40%. Bank loan would have a 15% rate. The rental payments would be $400,000. Lease payments would be $400,000 payable at the end of each of the next 4 years. That's important to remember. When we pay the lease payments is important here. Estimated residual, if you buy it, not if you sell it, if you lease it, is $250,000. And so then it asks us to calculate the NAL and IRR. So let's start working on this. Okay. So let's start with the purchase. So we're going to assume if we purchase it, we have to, we have a net purchase price. And I'm going to use Excel just to keep it, because there's a lot of writing and I would probably make a mess. But what I'm doing is not necessarily, you don't necessarily need to do it in Excel. And then we're going to have 4 years to this project. So we make the purchase at time 0, and that's a $1.5 million expenditure. Let me set all these. Get them in accounting format. All right, we have to pay $75,000 in maintenance expenses payable at the beginning of each year, whether the MRI is leased or purchased. So we're going to have maintenance expenses, and that's going to be $75,000. And I'm putting it at time 0 because time 0 is really the beginning of year 1, right? And we said we're going to pay the maintenance expense at the beginning of each year. So I'm going to pay the maintenance expense for time 1 at time 0. I'm going to pay the maintenance expense for time 2 at the end of time 1. I'm going to pay the maintenance expense for time 3 at the end of time 2. And I'm going to pay the maintenance expense for time 4 at the end of time 3. So anything you put in these in 1 through 4, you should assume is happening at the end of the period. Right? Now we usually assume that when we're working in finance problems, but sometimes we need to actually explicitly say it to make sure. And so it could be a little confusing where to put the payments, in particular for something like this. So when you're working with lease problems, really pay attention to when the payments are flowing. Okay. So if we have any new expense we incur that's not included in the, any expense that we incur is going to have a net income or a taxable income reducing effect. It will also reduce the net income, but it's going to have a taxable income reducing effect. So that means that if we pay for the maintenance, it will reduce our taxable income. That means that it reduces the taxes we pay. So, and we're in the 40% tax bracket. So maintenance tax savings are going to be equal to 0.4 times the 75,000, and it's actually going to be positive. So I have to have a negative. I have to make my 0.4 be a negative 0.4. So when I multiply it by the negative 75,000, it turns it into a positive number, or in this case, a positive 30,000, because those savings arise as a result of the reduced taxable income. So we reduce our taxable income by $75,000, which then reduces our tax expenditure by $30,000. So it's effectively, we're getting $30,000 back by reducing our taxes. So that's a positive flow. Then if we actually buy the equipment, we're going to be doing Macker's depreciation, so depreciation. And the problem, and of course that comes at the end of each year. It doesn't happen at the beginning. It comes at the end of each year, so the end of 1, 2, 3, and 4. And it's Macker's, so we're going to do 0.33 is going to, for year 1, our depreciation is going to be 0.33 times the 1.5 million. But what I'm actually interested in is not necessarily the depreciation itself, but the tax shield or tax savings resulting from the depreciation. So I'm going to take 33% of my 1.5 million, I'm making it negative, times 0.4, because that's my tax shield, right? So tax shield is 40% of the amount of depreciation. So I'm going to, let me just edit that, depreciation tax savings, right? I get my depreciation, so depreciation reduces the taxable income, and it reduces it in this case by 0.33 times negative 1.5, or 495,000, right? So the depreciation, when it hits the expenses, reduces my taxable income by 495,000. That results in a $198,000 reduction in taxes, because that's 40% of 495,000. So then in year 2, we also have depreciation, and it's 45%, so 0.45 times 1.5 million times 0.4 for the tax rate gives us a depreciation tax savings of 270,000. Then in year 3, it is, the Macker's amount is 0.15 times the net purchase price times 0.4. I get 90,000 in tax savings, and then again, in year 4, we get 0.07 times the purchase price negative times 0.4, 40%, and we get 42,000. So those are our, this line captures how depreciation reduces our tax savings. All right. And then we need to calculate our residual value. So residual value is how much we can sell the equipment for at the end of year 4, and we can sell it for 250,000. However, when we sell it, we have to pay taxes. So we have taxes on residual value. And in order to calculate that, we need to know how much what our book value is. And since this has been fully depreciated, right? It's a 3-year depreciation schedule. So 3-year Macker's actually gives you 4 years of depreciation. So at the end of year 4, we've taken the full purchase price. We have depreciated the full purchase price. So it has 0 book value, but we're selling it for $250,000, which means that the IRS is going to look at that as $250,000 in income. If we had some book value left, let's say $50,000 worth of book value, the taxable amount would be $250,000, the amount that we're receiving on the sale of the equipment, minus the $50,000 in basis, would give us a $200,000 taxable gain. But in this case, we don't have any book value, so we have to pay taxes on the full $250,000. So we'll pay 40% of the full $250,000, and that's going to be a negative because it's an outflow, right? It's an increase of taxes. as opposed to up here where we've had tax savings either from depreciation or from the maintenance. So now we have the net cash flow. And so we're simply going to sum these columns. All right. And so now we have our series of cash flows for the purchasing of this equipment. And now we want to do the same for the lease. And let's draw that out. So using these same columns, so this is our buy option. Let's do our lease down here. Leave a little bit of room. So with the lease, we don't purchase anything, but we do have a lease payment that we said was due at the end of each year. And the lease amount is going to be, where did I have it? So the lease payment is going to be $400. And it's actually going to start at the end of year 1, and it's going to go all the way through to the end of year 4. And then we have maintenance. Payment, which we said was due at the beginning of each year. And so that's going to be the same as up above. And then we'll also have maintenance tax savings. And as well as lease payment tax savings. So our maintenance payment is going to look the same. We could actually have left this completely out of the analysis. I'm putting it in here just because your book answer has it in here. However, I disagree with the book's book answer because they've consolidated the maintenance payment at the end of year 1 when the problem clearly states that the lease payment occurs at the beginning of the period, and they actually demonstrate that in the as that's the case in the buy option. So I think the book answer is actually incorrect based on the problem. So I guess you could believe me or you can believe the publishers, but based on my read of what they're saying here, the maintenance payment should be due at time 0 for both sides of this problem, both the buy and the lease. So that's how I'm going to solve it. Okay, and then the lease payment savings, right? So a lease payment hits our income statement as an expense, and then that reduces our taxable income by $400,000, which means that we get to keep or reduce the amount of taxes by 40% of $400,000. Which would be equal to minus 0.4 times 400,000 or 160,000. So let me just put that in here. And I've got to clean this up a little bit. There we go. Okay. And that is all the cash flows for the lease. And so we would just total these up. So negative 45,000 at time 0, and we'll just copy it across. And so here are our cash flows. Notice under the lease version, we're all negative, right? Under the buy version, we've got a positive and then a stream of negatives. So if you were doing your financial calculator, you could calculate the PV of these cash flows by using your cash flow register. Down here, you have to be careful to discount only the 4 out years and add those to the first one. So let's get the PV of each of these cash flows. PV of cash flow. We could call this cash flow by, and that would be equal to NPV. Oh, and we have to talk about what the discount rate would be. So the discount rate, if the bank loan would have an interest payment of 15%, let me back up here for a second. So the appropriate discount rate is going to be equal to the tax rate, one minus the tax rate in this case is 40%, times the bank loan rate, which would be 15%. So the appropriate discount rate is 9%. All right, so let me get back to that now. So calculating the present value of these cash flows going out to from year 1 to 4, I would use the 9% discount rate, capture all the cash flows, and then I add to it the cash outflow. I know you can't see it, but I'm grabbing it right now. And so we have a negative 1,044,000. That makes it look a little neater. Present value of cash flows for purchase. And I'll just copy this down here and change it to present value of cash flows for leasing. Right? And we need to bring back the cash flows out here to the present. So we have the present value of the lease cash flows is equal to the 45,000 we pay at time 0 plus the present value discounted back at 9% of the cash flows that happen in years 1 through 4. And so we have negative 936 as our cost of leasing. So now to calculate the net advantage of leasing, right, we would take the present value of the lease. So I'm just going to say equals this. And the present value of the purchase option. And let me neaten those up a bit, put them in, well, let me. So I'm going to subtract the present value of the cash flows of buying from the present value of the cash flows for leasing. So I'm taking a small negative, subtracting a larger negative, and I wind up with a positive 108,000. So the net benefit of leasing over buying is 108,000, a present value of $108,000. Okay, so my answer is slightly different from the book answer, again, because my interpretation of the way the problem is written is the maintenance payment on maintenance payments and their associated tax savings happen at time 0, 1, 2, and 3. The book answer has them shifted to the right 1 year, and I didn't see that changing in the write-up of the problem. Okay, so that's your using the NAL option. The other way that we could do this is we can do this as an incremental cash flow, and that requires consolidating the two cash flows together. Kind of the way we did the NAL, I'm going to subtract the buy option from the lease option. So I'm going to do equals, and I'm going to bring down my lease cash flow. In fact, let me net cash flow lease so I can distinguish it from net cash flow buy. So I would just, if I was doing this manually, writing it out, I would just write out what I want are the net cash flows from each of these options. And let me, like I said, neaten it up. I like seeing it in accounting format with no decimals. We're working with big numbers. We don't need decimals. So the incremental cash flow is the difference between the two. So I'm going to say equals this minus this. Copy it across. Okay, so basically we have what does this mean? So in year 0, let me freeze. Did I do that right? Nope, I didn't do it right. Oh yeah, I did. Okay. So at time 0, we would, if we did the leasing option, we would spend $45,000. If we do the buy option, we would spend $1.5 million. So the net benefit of leasing is we would save $1.5 million. Then in year 1, we would spend 200. We would have a cost of leasing of $285,000, but we would have a savings of $153,000. So effectively, by leasing, we would lose $438,000 in year 1. We would lose $510,000 in year 2, and so on down and out. So now we have those incremental cash flows. We could do. We could also still do the NAL, same way as before. Well, same. Treating this sort of like an inverted net present value project, where we do. It's going to be equal to the sum of the $1.5 million payment plus the present value of the out years. And the discount rate is 9%. And then I'm going to grab my out years. And as you can see, I get the same result, right, as before. It's just a matter of order. But we do need this to do our IRR. And that doesn't like. And again, my IRR is slightly different than the book because I have because again of the fact that I put the $75,000 maintenance payment at time 0 in the lease. So the book answer is 5.3%. I come up with roughly 5.6% for NAL. But it is consistent here. Now, the way you interpret the IRR in this case is, and this is going to run counterintuitive based on everything we've done with IRR up till now, but you actually want an IRR that is less than your cost of borrowing. So in this case, we have an IRR resulting from the lease of 5.59. So that's less than the cost of borrowing. So that verifies that the lease is an advantage, just like the net advantage of lease does. So just remember, you want to go below your cost of borrowing rather than above your cost of borrowing. Okay. So now part B says, assume now that the salvage value estimate is $300,000, but all other facts remain the same. What is the new NAL? Well, that's easy. Since we did it in Excel, it's easy. All we have to do is go change our residual value from 250 to 300,000. So we plug in 300,000, and that changes the present value of the cash flows for the buying. It doesn't have an impact on the leasing. But when we go down here, it reduces our NAL. It makes the buying more attractive. Why? Because we're earning more money when we go to sell the old equipment. So that gives more cash to the buying option. And it increases our IRR to 6.3%. Now, notice the IRR at 6.3% is still less than, right? It's still less than 9%. So that's still a go. And the NAL is greater than 0. So that means it's a go, right? So even though the increase in residual value reduces the benefit of leasing, it doesn't overcome the benefits of leasing. And so leasing, because the NAL is still greater than 0 and the IRR is still less than 9%, this is a go.